Today we're going to talk about graphing linear inequalities. That means we're going to create a line and we're going to graph it by looking at inequalities which have more than one answer. So we're going to have to shade that. So if we look over here at an example, we have our line right here, and you notice one side is colored purple. That's because that's the answer to the inequality. So we're going to create this type of graph when we do the problems. So let's take a look at problems. The first problem we have here is we have to get this into graphing form, and the best way is to put it in slope intercepts. So that's y equals mx plus b. So to do that, we have to isolate the variable y, so I'm going to subtract x. So let's write the equation and subtract the x from both sides. And when we subtract the x, we cannot subtract it with the 2 because it's not a like term. Then we have to get rid of the 4, so we divide each by 4. And so we end up, and I'm going to put the 1 in that's invisible so I can see the number, reduce this fraction, so that's 1/2. Now we can graph this by going to 1/2 on the y-axis, and 1/2 is roughly right here, and we're going to go down 1 and to the right, 1, 2, 3, 4, 1, 2, 3, 4, and because our inequality does not have a line underneath it, that means it's not equal to, we're going to do what's called a dotted line or a dashed line, and that creates our line. Now the next thing is doing the inequality. To do the inequality, what I like to do is look at the point 0, 0 because it's the easiest point to substitute into the equation. So point 0, 0, 0 goes in for y and 0 goes in for x, and we have 1/2 left over. We look at this inequality. Is 0 bigger than 1/2? And that's false. Since it's false, this point is not part of the answer, so we have to shade away from that point. And so there's our graph of our inequality. So let's do one more to go through that same process again. So I got to get this in slope-intercept form. So this time I'm going to add x. So let me copy the equation, add x to both sides. Divide each side by 2, or every 2. This isolates our y. This is 1/2 x, and when I simplify, that's 2. So I go to 2 on the y, I go up 1, and to the right 2. Oops, I made a common mistake. Once again, the inequality is not equal, so it has to be a dashed line. So I do my dashed line. And then once again, I'm going to use 0, 0, this point right here, as my, so I put 0 in for y, 0 in for x, and then I look at this inequality and see if it's true. 0 bigger than 2, once again, that's also false, so this point cannot be part of the shading, so I shade away from it. Now if it's true, I would shade that point, but since it's not true, I shade away. One more that looks a little different in this problem right here. It's already in slope-intercept form, but it doesn't have an x. So we're going to go to the y line and put our dot on 2. And now what we have to do is graph that. We'll graph it is we're looking at a line, but it happens to be a horizontal line connecting that dot. And we're going to then shade. So if I do the same thing, check my 0. If I put 0 in here, is 0 bigger than 2? It's false. So I'm going to shade away from that, which is up here, and that's our inequality.